Cache coherence is one of the biggest issues raised by parallel computing. Let's take a look at an illustration. Here is a loop that is designed to be run in parallel. The parallel portion just adds a value to a running sum. The addition statement is surrounded by a lock so that only one thread can execute it at a time. The lock is acquired, the addition is done, and then the lock is released. Suppose that A1 is 3 and A sub 2 is 7. Will it print sum equal 10? And if not, how can the locking be changed so that the sum will be correct? Well, we have a system of n processors in this animation in a shared bus. Different processors can add values to the shared sum. At the start, let's say that all caches are empty and the value of the sum in main memory is 0. Then P1 tries to read the value of the sum. It looks in its cache, but the value isn't there. So it sends a request on to main memory, which returns the value 0 to the cache. The value 0 is stored in the cache for the sum variable, and the state is set to V, which means valid. Now P2 tries to read the value of sum. It's not in its cache either, so it sends a request to main memory, which returns the value and puts 0 in the cache in state V. Now P1 writes the value 3 to sum. The value in its cache changes to 3 and the state changes to D or dirty since the value has been updated since being read in from main memory. Now P2 adds 7 to its old value of sum, which was 0. It writes the new value 7 to the cache and changes the state to D. P1 now reads the value of sum, and it sees 3, so the addition did not take place. The sum should be 10. This raises several questions, which I'll let you consider now and during the quiz, but we do want to answer the second one. Does it matter if we use a write-through cache? Using a write-through cache does not solve the problem. With a write-through cache, when P1 writes 3 to its cache, the value is written through to memory. Then when P2 writes 7 to its cache, that value is also written to memory, overwriting the 3. Thus, memory ends up with 7, which is not equal to 10, and thus is not the correct sum.